We live in a digital world today. For example, most people have smartphones, and even these by themselves can generate vast amounts of data. Processing such large amounts of data presents new challenges, and these are challenges in common to all sectors of the economy. A new term, big data, is used to describe this field. Analytics on big data presents tremendous opportunities to gain further insight in problem domains. A subset of this is performing analysis in real time on data that is streaming at high rates. For example, in the financial markets, high-frequency trading on option contracts. Another example is in medicine, when processing readings of physiological parameters measured by sensors at the patient bedside, such as in intensive care. NanoStreams explores the market potential of real-time streaming data analytics via targeted use cases. The project, which is a collaboration of 7 partners, is funded by the European Commission under the ICT theme of its Framework 7 Programme. NanoStreams aims to meet the unique technical challenges of processing many concurrent data streams in real time. The project tackles this challenge using a novel microserver architecture and a novel software stack that is co-designed with the architecture.
This is a mechanical ventilator which saves lives by giving breathing support, and we have 2 bags which represent lungs. During mechanical ventilation, sometimes you can end up giving too much support, which translates to more gas flow or even increased pressures within the lung. And this itself, unfortunately, can damage the lungs and lead to increased risk of death and worse outcomes. Here I'll demonstrate 2 different amounts of gas flow, and you'll see how the bags which represent the lungs inflate to different sizes. Now, you would have appreciated with the lower amount of volume of gas, the inflation or the stretch of the lung setup is a lot lesser, and this will decrease lung injury. So, by using an automated, rapidly responsive alert system, we hope to decrease lung strain, lung injury, and also improve patients' outcome in all patients who undergo mechanical ventilation in ICU.
The NanoStreams microserver tries to pack the compute power of a conventional rack-mounted server that measures almost 20 inches wide and 40 inches deep onto 2 systems on chip packaged on 2 cards that measure about 2 inches wide and 2 inches deep each. The microserver consumes roughly 10 times less power than a conventional counterpart. However, the microserver performance is equivalent to that of the conventional server because parts of the microserver can be customized to perform efficiently specific operations on streaming data. NanoStreams innovates in many ways. The microserver architecture breaks current barriers of energy inefficiency in computing systems. The software stack improves programmer productivity. Programmers can write large streaming applications and accelerate them in hardware using just a few lines of C code. The whole NanoStreams hardware and software appliance can reduce significantly the operational costs of data centers.
It is clear that power consumption is a growing concern for data servers, and interest in alternative computing platforms has been growing. Field Programmable Gate Arrays, or FPGAs, represent an interesting lower power alternative and are gaining a lot of traction with interest from companies such as Intel, IBM, and Microsoft. The key challenge is the programming times involved, as they require specialist programming languages and longer design times. In NanoStreams, we are directly addressing this issue by the creation of NanoCore, an optimised processing solution on FPGA, which allows the programming times to be dramatically reduced while maintaining performance gain. The NanoCore architecture and associated compiler has been created and applied to a number of data processing and medical applications. The work opens up the potential of using FPGAs in a wider range of data servers and applications.
Ethernet plays an important role in the data center. It is ubiquitous, cost-effective, and its link speed scales with technology. NanoStreams explores the use of Ethernet as a physical layer to communicate between servers and accelerators. Research in NanoStreams innovates with new protocols and a lean software stack on top of raw Ethernet. NanoStreams drives overheads down to a few microseconds per task without any custom interconnect hardware. In addition, we argue for sharing rack-scale accelerators across servers. This is important for improving utilization of resources and increasing return on investment in the data center. We believe NanoStreams will lead to broader adoption of accelerators in the data center and in data analytics applications.
New computing systems technologies to tame the data deluge create immense market opportunities. The microserver technologies themselves have a potential market in excess of 30 billion euros within the next 3 to 5 years. The software services that these technologies enable have a market potential in the region of hundreds of billions of euros, according to market analysts. In addition, these technologies can create up to 200,000 jobs across the European Union.